A conducting circular ring is rotated with angular velocity omega about point A as shown in the figure. Radius of ring is A. Find potential difference between point A and C and potential difference between point A and D. In first case, we find potential difference between point A and C. Here, circular ring is rotated about point A in clockwise sense with a angular velocity omega. Now let potential at point C is Vc and at point A is Va. Now we find the force on the free electron of a conducting ring by using Lorentz formula F equal to Q V cross B. Here this is the relation is for the positive charge particle. Now we find the direction of force for the positive charge particle, then for negative charge particle. Now for positive charge particle, here ring is rotated in this direction, so positive charge particle at point C is directed towards this direction, and here magnetic field is directed into the plane of the paper, and so the force can be, so the direction of the force can be found using Fleming left hand formula. Here magnetic field is directed in the direction inwards the plane of the paper, and the positive charge particle is directed in this direction, so the force on the positive charge particle is towards the point C. So positive charge particle can accumulate at point C, and if we consider for negative charge particle, so the force on the negative charge particle electron is opposite to the positive charge particle, so that is negative charge particle is accumulate at point C. So the free electron of the conductor is accumulate at point C. Here we see that magnetic field is directed inwards to the plane of the paper, and the positive charge particle is directed in this direction, so the force is in this direction, that is directed towards C. So the negative charge particle is directed towards A, that is negative charge particle is accumulate at point A. So the potential at point C is greater than potential at point A, since the potential at point C is positive potential and the potential at point A is negative potential. So Vc minus Va is equal to half B omega L square. This is the potential difference when a charge particle, when a circular ring is rotated in magnetic field. This is the relation. Here L is, that is AC, this is 2A, since the radius of the ring is A. So Vc minus Va is equal to half B omega L is 2A whole square. So Vc minus Va is 2B omega A square. Now for second part, that is potential difference between point A and D, and this is A, so the distance between A and D is root over A square plus A square, so this is root 2A, L equal to. Now here the for the positive charge particle at point D is directed in this direction, so magnetic field is directed inward direction, and the velocity of the charge particle is this direction, so the force is towards D direction. So the positive charge particle is accumulated at point D and negative charge particle at point A. So the potential at point D is greater than potential at point A, and since Vd minus Va is equal to half B omega L square, so half B omega, here L is root 2a, so Vd minus Va is equal to B omega square.